Today we will learning about intermolecular forces. Intermolecular forces, you can see inter is between. And the molecular is molecule. So intermolecular forces is attraction, is the forces between a molecule. So at the end of the class, you will be able to describe types of intermolecular forces possible between atoms or molecule in condensed phase. We discussed about 3 different types of intermolecular forces. First one is dispersion force. Second one, we will learn about dipole-dipole interaction. Third one is learn about hydrogen bonding. And also we discuss about strength of the intermolecular force. You will see dispersion force will be weakest. And the hydrogen bonding will be strongest. And also you will be able to identify types of intermolecular forces expressed by specific molecule based on their structures. So why we did know about types of intermolecular forces? This is a good example. Water is liquid. Carbon dioxide is gas at the room temperature. Both compound is a molecular compound. But why they have a different property, physical property? To explain the observed behavior of this kind of molecule in molecular terms, we need to introduce type of intermolecular forces. Also, we can see this is the water molecule. This is a solid state, and this is a liquid state, this is the gas state. What changed when the molecule changed phase? Now we will examine the water molecule. This is a water molecule. You can find water molecule in solid, liquid, and gas. And you can see the solid state. This water molecule held together by something, which is a attraction, by attraction. They hold it together. So this is called non-bonding interaction. So intermolecular force is non-bonding interaction. So we need to distinguish 2 forces. One is the intramolecular force. It's a covalent bond. In this case, it's very strong. And also intermolecular force, which means attraction between molecules, but it's a weak. So the force will be 0.5 to 40 kJ per mole. But intermolecular force is very important to understand physical property of substance, such as boiling point and melting point, or solubility. So try to understand physical property of a substance. We know about what is the type of intermolecular force. So today we'll discuss about 3 main types of intermolecular attraction. Just say hydrogen bonding is the strongest. Dipole-dipole interaction second, stronger for more polar molecule. Dispersion force is stronger for larger, more polarized particles. We discuss in more detail each forces. Dispersion force also called the London forces. So we first discuss about dispersion force. This is called the London force. Also, this is called the van der Waals force. This attractive force is the result of a distortion of electron cloud when the molecules come together, close together. they induce temporary dipole. This is showing about electron deficient area with a temporary positive charge. This electron-rich area, they're making a negative charge. So they make a dipole, temporary dipole they have attraction force. So this is attraction force, say dispersion force or London force. So next slide showing about the effect of a diversion force. This is fluorine, chlorine, bromine, this halogen atoms. So fluorine, bromine. This is molecular restructure of this molecule. You can see fluorine is, this molecule is non-polar molecule. And also you can see molecular mass is increased. And also atomic radius is increased, which means more electron. And the melting point is increased, boiling point is increased. So from this table you can observe the bigger mass molecule with the bigger dispersion force, because you can see the melting point and boiling point higher. So now you can rank the following substance in order of increasing strength of dispersion force. They are atoms or molecule experienced in the gas phase. From this four molecules, you can see this is noble gas. This is you can say this is non-polar molecules. So we examine the molecular mass of each atom of molecules. Helium is 4 grams per mole, 158. Carbon dioxide is 42 grams mole, methane is 16 grams mole. So you can find strongest dispersion form is bigger molecular mass. So bromine will be the biggest, the strongest dispersion force. Helium will be weakest dispersion force. So we can write now based on molecular mass, and you can say bromine is strongest, the carbon dioxide, methane, and helium. This is in order. And also strength of dispersion force increases with the contact area between the molecule. This is an example. This organic compound contains same number of carbon and hydrogen. And you can see it has a large contact area, which means we expect strong attraction. This one showing about a spiral, and this has a small contact area. We expect weakest attraction. And we can say boiling point is lower, is higher than this one. So we can explain the boiling point by dispersion force, also the contact area, also molecular mass. The second way to learn about the dipole-dipole interaction. This attractive force that exists between polar molecules such as HCl. Chlorine is electronegative atoms, so showing about partial negative charge. Proton, hydrogen is partial positive charge. And they have a dipole between two atoms. So this dipole moment making interaction, making attractive force. So this is called dipole-dipole interaction. So what is different between dispersion force, dipole moment? Dipole-dipole interaction. This dipole-dipole interaction is permanent dipole-dipole interaction. Dispersion force is induced dipole-dipole interaction. So this is the difference. So you can predict which will have the highest boiling point, nitrogen and carbon dioxide. This is non-polar, this is polar. So this have a dipole moment. So this will be, we expect this molecule will be higher boiling point. So last we discussed the hydrogen bond. So you can see that this molecule contains OH groups showing a unusually high boiling point. So because they form a hydrogen bond. So what is hydrogen bonding is possible for molecules that contain hydrogen atom covalently bonded to nitrogen, oxygen, or chlorine. So hydrogen is covalent attached to the something, which one is nitrogen, oxygen, or chlorine. They have interaction with another molecule is containing a nitrogen, oxygen, or chlorine. So even though hydrogen bonding is safe bonding, but still you need to distinguish this is not the actual chemical bond, covalent bond. This is non-bonding interaction. So you can say using a dot is showing about hydrogen bond. So you can see the effect about this adding hydrogen bonding force on the boiling point of group 6A. So you can compare these molecules. Water molecule is highest boiling point because of hydrogen bonding. So now we can identify the following. Identify the intermolecular forces that expect for each of the following substance: the methane, trichlomethane, and butanol. And the methane is non-polar, trichlomethane is polar molecule, butanol is containing OH groups. We may expect hydrogen bonding. So first one is non-polar because of non-polar molecule. Second one, expect dipole-dipole interaction, but also there is a random force. Butanol also you can expect hydrogen bonding because of OH groups. And also expect dipole-dipole force and random forces. The random force is a universal interaction between the molecules. So we learn about types of intermolecular forces, also strength of intermolecular forces. So we can apply this knowledge to the biological system. This is the protein, this is the ligand. How the protein interacts with the molecules. We can identify, you can observe the hydrogen bonding between this protein and ligand. Also you can find some ligand, hydrogen bond between here. Also you can expect some dipole-dipole interaction, also a van der Waals interaction. So today we learn about intermolecular force. We discuss about dispersion force, dipole-dipole interaction, and hydrogen bonding. This is strength of each forces. We understand of these forces to explain physical property, and also we can apply in biological system to understand the nature. Thank you.